So hello everyone. Today we are going to solve our fourth question, which is remove duplicates from sorted array. And we have already solved the previous three questions. If you haven't seen it, please see. And so let us solve the fourth question. The fourth question is similar to what we had done previously. And yeah, so we have given the nums array and it is increasing order and we have to replace the elements. We have to remove some duplicates. The thing which changed is that we can allow the element twice, means we can have the element at most twice. The relative order will be the same. We cannot change it. And the similar things are there. So, and we have to also do it in O of one space complexity, means which we cannot use any other data structure for storing the array. And yeah, so a similar case will be there. So let us move and solve this question. So how are we going to solve this problem? So we can allow an element at most twice. Means if it is occurring more than twice, we have to remove it. Or if it is occurring less than twice, then we should just replace it at the starting of the array so that we can get the output array, this one. And we can return up to this element. So how are we going to do? So we can maintain a boolean so that we can check if the last element before this was also the same element. And if it is false, it means that the element is unique. And if it is true, then if it is true means it has been repeated. So we can check if the element is occurring more than twice using an variable which is temporary. So we have named it temporary. It can be a boolean or a count. I have taken it as boolean so that it will be easy, true and false. So let us see how we are going to solve this. So what we will do is that we will traverse the array. Similarly, what we did in previous problem, we will point it an pointer I at the starting of the array where we are going to replace the element, and we are going to traverse using j and have a unique elements and replace it in the position of I. So let us see. And so we are going to point an I pointer to the 0th index, j pointer to the first index, and the temporary will be false because we have not seen any duplicate till now. Or let it be mark it as duplicate. Is duplicate. So it will be easier. Is duplicate is equals to false. So currently it is false. So we are going to iterate it. We will check if the element at j is equals to element at I. It means that the number is repeating. And if the number is repeating and the duplicate is false, which is means it is not yet occurred more than twice. Because if it has occurred more than twice, then this would have been true. Let us see how we can do that. So we are also going to check the second condition, which is not false. Not is duplicate. So in this case, if it is not happened, it is not occurred yet, but it is equal, then what we are going to do is we are going to mark the is duplicate as false because now we it is repeated. The 0 is repeated. So we will mark it as duplicate. What we will do is that we will place the next index, which is I plus 1, with the element at index j. Now it will be similar like j is at 1 and I is at 0. So I plus 1 will be 1 and j is also 1. So we will replace it. But what will happen in the cases where the j will be at a far away position from I? So we have to replace this element at the starting of the array. We can see that we have to get the elements at starting because we cannot use any other extra space. So we have to modify the existing array itself. Now what we will do is that we will increment the I pointer. Okay. What can be the other conditions? If the element is not equals to the element at I. Now what we can do is that if the element at j, so we are going to increment it. So let us move first so we can understand it better. So we are at point j and we are at point I. Now the value is true because we have set it here. True means the element is repeated. 0 is repeated. Now we are at point j. The element is not equals to the element at pointing at I. So it is unique element means we can use this same thing, which is place the array, place the element at index I plus 1. J, and similarly we can mark it as false because it is a new element. We can see that 1 is a new element, so duplicate we have to mark it as false. We will similarly increment the I pointer, and we have to remember that we are traversing from j is equals to 1 to j is less than n. N is what? The size of array. And also we doing is we are incrementing the j pointer as well. Okay. So what we will do? We will place the element at I with the I plus 1 at the element 1, which is 1 is replaced by 1. So this is the condition. And what we will see the next condition, like if the element is occurred more than twice, if it doesn't satisfy both this condition, then what will happen? So here j will be moved forward, I will also move forward, the duplicate is false, and okay, now the duplicate is false and we are at j. So if it is equal to 1, okay, yes, it is equals to 1. And we can see that it is false means it will be the true, the whole condition will be true. So this condition should happen simultaneously. So if duplicate is false, this condition will be satisfied and we will execute this code. What will happen is we will mark it as true because we can see that one is duplicating means one has repeated. Now we will replace the one with one. I know we are doing the same thing, but it will be seen that it is making a difference. So let us see. Similarly, this will I increment. J is incremented by the loop. The I will be moved here. We have to mark it as, okay, so sorry, this was the case. We have to mark it as true because it is duplicating. So sorry for that. And this duplicate is true. Now we came it here. Now what will happen? If we got, if it is equals to, yes, this satisfies the condition. If is duplicate, yes, it is duplicate. Not means the condition will be false. Means that this condition will not be implemented. Let us move to the second condition. Second condition is it is not equals to. So what is happening is that the element is duplicating more than twice because that's why it is not satisfying this condition. So what we will do is that we will skip the element. That's what we did in last question as well. We will skip the element because we don't want to do anything with this element. We want the unique elements, and what we'll do is that move that unique elements in the front of the array. So what we will do, it doesn't satisfy any condition, we will move the j pointer. Similarly, same condition, no satisfied condition, we will move again the j pointer. We got the unique element, means it is not equals to. What we will do, replace this 2 with the I plus 1. It means that our index is at I, and what we will do is that replace the next element with the element pointing to the j because j is pointing to the unique element. So we will replace this. This is the condition. We will increment the j pointer again. We will mark it as true. It is already marked as true. It is already marked as false, means we have to mark it false. So this duplicate is false. This condition is satisfied. Not this one. I'm sorry. So we are at here. Is duplicate false? It is not equals to nums of I. Okay. So another one, we will replace this with 3. and increment j pointer, increment I pointer. Again, we can see that duplicate is false and we have got the element equal, means the element is repeating. So this condition will be satisfied because it is not occurring more than twice. That's why this condition is satisfied. So this condition is for checking if it is occurring less than twice. So what we will do is duplicate true, mark it as true. So, so we will place the element 3 at here, and we will again increment the I pointer and increment the j pointer. So j has crossed the limit, means it is greater than the size of the array. We will stop it, and there we got the answer, which is output array, and we don't care about the last element. And we don't care about the last element. What is that? We want it up to this element, because in this case, we will not be having an element which is more than twice. So now what we have to return? We have to return the k, means the element up to which the array is valid. So this is the index up to which element is valid. Okay. So what is will be the index? So we can return the index I. We can return the index I, because I is our answer. We have reached at this index and this is our answer. So I will repeat it what we have done in this. We are using one boolean to store if an element is repeated or not. And we are checking it one condition, if it is similar to the element pointing at j, and if it is not duplicate. If this is false, means it is new element, and if this is true, means it has occurred only once. So this condition will give us that if element has occurred and it is less than the count 2. So this condition will satisfy, and this condition is for if it is element is completely new, means unique element. So we don't have to do anything, just replace it at the start of the array. And if it is duplicate and happening more than the 3, means if it is happening more than twice, so the condition will not satisfy, either of this condition won't satisfy, and we will skip that element. Just like what we did with the, where is the original array? The original array is this one. Okay, so what we did with this one, what we did with this one is we skipped this. We also skipped this. So we skipped both elements because this were occurring more than twice. So this was the this was the question. It was simple. We have done it in the previous questions as well. So we have solved this question. So what if the question asked us to allow at most 4 occurrence of an element, or at most 5 occurrence of an element? Then we could have approached the question with different strategy. Means we could have used here an count element, which tracks the occurrence of the elements. So how could we have done that? Or this is solution for the general case. The current question is done. We can done it using the boolean. This is for kth occurrence. Mean this is general case. What we could have done? We can initialize the k to 1. Let me remove that, because this is the old array and we have to use the new array. Similarly, I will be pointing to here, J will be pointing to here, and we have the count variable. Okay, so now we can see that element is repeating. What we would have done, same, we can remove this because we are not going to use this. If the element is same, what the ideal situation would be, increase the counter. We will increase the counter. If it is not same, what we will do? We will set the count to 1 because it has occurred once. We will set the counter 1, and if it is occurring, it is similar, then we will increase the counter. So this is a condition. Now we are going to check one condition as well, and this is important for this case. What we will check is if the count is still less than 2, means the question is allowing us to have at most twice occurrence. So this is the thing which we can replace here, kth occurrence, means we can allow kth occurrence of an element. So in the place of k, we can use here 2. What we will do in this condition, we will do is similarly what we have done in the previous approach. We will replace the element at index I plus 1 with index at. Now we will just increment the I pointer as well. the J pointer will be incremented in the loop itself. So let me place this here. So what we have changed here is that we have used a counter to track the number of occurrence of an element. So if the occurrence is less than 2, then it means that we can allow it and we can have it in array or valid array. This is the valid point. And if it is greater than 2, this means it is duplicate and we are going to skip that. That's what we did in previous approach as well. We skipped the element. We skipped this element, this element and this element. So similarly, we are going to skip these elements in the this approach as well. So this is the approach. So let us see the code. The code is very similar to what we have discussed here. This is the pseudo code and this is the actual code. Very similar. We can see that we have used the same condition. What we did is we will initialize the base case. If the element, the array contains only one element, we will return that. We have initialized the count. We have initialized the pointers. We are traversing over array. We are returning I plus 1 because we want to return the maximum element and we are at index I. So we have to return an element. We have to return number of elements. So we will return I plus 1. So this is the thing. We are going to run this and check this if it is working. It works. Let us see the time complexity. Time complexity is O of n. Why? Because we have traversed it over whole array using J pointer. So time complexity is 1, means O of n, and the space complexity, which is important here. The space complexity will be O of 1. We have not used any extra space, so space complexity will be O of 1, and this is what we wanted. This is the question demanded. We have to use O1 of extra memory. So that's what it from this video.